All right, guys, I hope you guys are behaving for the substitute. Today we're going to go ahead and take some notes on factoring by grouping. We're going to go through each one of these steps one at a time when we start solving the problem, and I've broken up today's notes into each of those steps. Before we begin, I want to talk about what a GCF stands for and what the definition is. So in your small groups, I want you guys to go ahead and decide what you think it stands for, those three letters, and what it means. So we can pause the video until you guys have figured that out, and then we will come back together here in about 30 seconds. All right, GCF stands for greatest common factor. And that greatest common factor is exactly what it says. It is the largest factor or number that they have in common. Now, you can find a GCF by breaking a number down. Back in the day, when you were in elementary and stuff, they would say, what's the greatest common factor of, let's say, 16 and 8? So they used to have you make factor trees. So you would say 16 breaks up into 4 times 4. The 4 continues to break up into 2 times 2. This 4 also breaks up into 2 times 2. Now let's factor out 8. So these can break up into 2 times 4, and the 4 continues to break up into 2 times 2. So what is the greatest common factor? They each have 1 2, 2 2s, 3 2s in common. What is 2 times 2 times 2? 8. Therefore, their GCF that they both have in common is 8, the largest factor that they are both divisible by. All right, so we're going to use that skill today in our factoring by grouping. This allows us to factor any problem, whether it's got 4 terms, 3 terms, 2 terms, it doesn't matter, and they're all the same difficulty. We can do the hardest problems just as easy as we would the easier problems. All right, so let's look at this problem. Step 1 says to separate the problem into 2 parts. This is really tough. Think about this. We've got 4 terms separated into 2 parts. So let's just split it right down the middle. All right, step 1 is done. Tough, wasn't it? All right, so now we've got to find the GCF of each of those parts. So let's first start with this first half, 4n cubed and an 8n squared. I'm going to go ahead and do the factor tree method, and eventually we can step away from the factor tree method after you start to get the hang of things. So let's go ahead and break down the 4. 4 is 2 times 2. N cubed is the same thing as n times n times n. All right, let's go ahead and factor out the 8 now. 8 breaks up into 2 times 4, and the 4 breaks up into 2 times 2. I've used the 4 so I can cross it out. This is n times n. Now, let's go ahead and see what do they have in common. They both have 1, 2, 2s. And they both have 1, 2 n's. So the GCF of the first part is 2 times 2 times n, or 4n squared. Okay? All right, so let's go ahead and look at the other side now. We're going to break up that 5n and that positive 10. Well, 5 breaks up into 5 times 1 with 1n. 10 breaks up into 5 times 2. All right, so what do these two have in common? They both have 1 5, and that's it. So their GCF is a 5. All right, so the next step says to divide out that GCF. Now, essentially, you could go back up to that original problem. If I had 4 divided by 4, I would have 1 left over. N cubed, taking out 2 of those n's leaves you with 1 n. So when you divide it out, 4 divided by 4 we said was 1, and we said that we had 3 n's and we canceled out 2 of them, so we're left with 1 n. Now, what I like about the factor tree method is, look what's left over. Right here, what was left over in that first term? 1 n. So that kind of leaves you with what's left over. All right, so let's see what's left over in this part. What is left over? 1, 2. So the left over would be a 2 there. Now, you could have also done it the division method. 8 divided by 4 is a positive 2. If I had 2 ends and I canceled out 2 of them, I would have no ends left over. So that is done. This 4n squared times that parenthesis is the same thing as this if I were to distribute it. All right, let's do the other side. I have a 5, and I always bring down that plus sign. So it's a positive 5. All right, what's left over? What is 5 divided by 5? 1, and I have 1n remaining. 10 divided by 5 is a positive 2. Or I could have looked at my factor tree and I saw that I had a 1 and an n left over in the first term, and I had a 2 left over in the second term. So this is pulled out. Now, what I love about this method is if you did it right, it will basically tell you, because these will look exactly the same. So the finalized answer would be 4n squared and a positive 5 in one parenthesis. And where did I get that? Because I did this has to get multiplied by that parenthesis, and this has to get multiplied by that parenthesis. So 4n squared is getting multiplied by that whole parenthesis, 1n plus 2. And the 5 has to get multiplied by that whole parenthesis, 1n plus 2. This is like the reverse of what we did. Instead of distributing it, yes, that's what it's doing. If I were to check it, I can go back and distribute it to make sure that it comes back to that original expression at the very top. All right, so let's do the next one a little bit faster. Okay, so we're gonna do this a little bit faster. You can always pause the video or rewatch it later if you want. So we're gonna draw our line down. What number goes into both 5 and 20? The largest number that goes into both 5 and 20. And again, if you can see it right off the bat, then do it. I can see right off the bat that it's a 5. How many t's do they have in common? This one has 4 t's, this one has 3 t's. So they both have at least 3 t's. There's my GCF. Now, you also could have done the factor tree method. This is a 5 times 1 with 1, 2, 3, 4 t's. This is a 5 times 4 with 1, 2, 3 t's. And again, they both have at least 1 5, and they have 1, 2, 3 t's here, and 1, 2, 3 t's over here. So when you're pulling those outside your parenthesis, then you can find out what's left over. Okay? So we will transfer that down in just a moment. Let's go ahead and do this. Again, if you want to do the factor tree method, you can. What is the largest number that goes into both 6 and 24? 2 goes into both of them, 3 goes into both of them, but the largest number that goes into both of them is a 6. They do not both have a t, so I can't even pull out the variable. Again, I'm going to do it the factor tree method, 6 times 1 with 1 t. This one is 6 times 4, but both of those can break up into 3 times 2 and 2 times 2. And again, you can see that, well, I forgot to break that down, but it's still a 6. So yes, I can still break that down. 6 goes into both of them evenly. They both have at least 1 3 and 1 2. All right, so let's go ahead and factor those GCFs out now. Okay, we've determined that our GCF was a 5t cubed. What is left over in this first term? 5 divided by 5 is 1. T to the 4th, take out 3 of those t's and you're left with 1 t. 20 divided by 5 is 4. If I had 3 t's and I'm taking out 3 of them, then there are none remaining inside my parenthesis. Bring down that symbol. That plus sign always comes down. Whatever symbol is in front of this right after that line, then that's the sign that comes down. All right, we said that our GCF was a 6 here. 6 divided by 6 is 1. I have 1 t left over that didn't get pulled out, so it's 1 t. 24 divided by 6 is 4. Now, if I did it right, my parentheses should match. This parenthesis says 1t plus 4. This parenthesis says 1t plus 4. So now I can write it out. What gets multiplied by that parenthesis 1t plus 4? They have that common parenthesis. What is getting multiplied by it? A 5t cubed and a positive 6 are both getting multiplied by that t plus 4. Now, going through and checking it, look what happens. Yes, that's exactly what I just said. This 5t cubed got multiplied by that entire parenthesis t plus 4. Okay, 5t cubed times 1t should be a 5t to the 4th. 3 t's, t times t times t times 1 more t. 5t cubed times 4. 5 times 4 is 20. And I have 3 t's remaining. All right, now we're going to take that second value, 6, and gets multiplied by that whole parenthesis as well. 6 times t is 6t. 6 times 4 is 24. Is that the exact expression that I had at the very beginning? Yes. Therefore, I did it right. All right, I want you guys to try that next problem real quick on your own, and then we can check with our small groups, and then we'll check together. So go ahead and pause the video, and then we will come back and check it in just a moment. All right, so let's go ahead. I'm not even going to worry about these boxes. I'm just going to do it like this. The boxes are there to help you, but I'm going to do it without the boxes. So step 1 says to separate that into 2 problems. Second step, find the GCF of the first half. What number goes into both 10 and 25? If you need to do the factor tree, you can. That would be 5 times 2 with 1, 2, 3 p's. This would be 5 times 5 with 2 p's. What do they have in common? They both have 1 5. They both have 1 p here that I'm pulling out and another p that I'm pulling out. What is 5 times p times p? Is 5p squared. I'm not even going to leave an extra spot. I'm just going to go ahead and write down that parenthesis. Divide it out right now. What is left over in the first term? A 2 and a p. What is left over in the last term? A 5. Now, the question is, sometimes that sign stays, sometimes the sign goes. So we need to talk about that. It helps when you do it division. 10 divided by 5 is a positive 2. Negative 25 divided by 5 is a negative 5. So in this case, I did bring it down. Okay, so let's go on to the next part. Again, we're always going to bring that plus sign down. What do a 4 and a 10 both have in common? Well, 4 is 2 times 2 with 1 p, and a 10 is 5 times 2 with no p's. What do they have in common? They have 1, 2 in common, and that's it. So let's bring that out. What is left over? In the first parenthesis, I have a 2 and a p left over. So 2p. And in the second one, I have a 5. Let's check our signs. 4 divided by 2 is a positive 2. Negative 10 divided by 2 is a negative 5. Do my 2 parentheses match? Yes. Therefore, that common parenthesis is 2p minus 5. What are both parentheses getting multiplied by? A 5p squared and a positive 2. Now, let's go ahead and check it. This gets multiplied by this. 5p times 2p. 5 times 2 is 10, p to the 3rd. 5 times 5, 5p times p times 5, negative 5, would be a negative 25 p squared. Again, it's 5 times a negative 5. Now let's take the 2. 2 times 2 is positive 4 with 1 p. 2 times a negative 5 is a negative 10. There are no like terms, so there is my answer. Now, did this come out to that original problem? Yes, that is the exact same expression that I had in the original problem. So this is my answer. This was the check. Okay? All right, so I have some practice for you guys. I want you guys to go ahead and do the practice, and then we will try some more tomorrow. Thank you.